All right, in this review problem, we're going to take the sum of these two trig functions, 4 cosine 6t minus 3 sine 6t, and write that as a single trig function, a cosine of b times t minus phi, for a, b, and phi are to be found. Before I do any work on this, let me just do some graphical exploration of this. If you draw the graph of this, 4 cosine 6t minus 3 sine 6t, and just draw the graph, it does indeed look like a single sinusoidal function. So the graph bounces up and down like a single sine function. Now, the thing that's kind of surprising is that the amplitude looks like it's 5. So it's bouncing between plus 5 and minus 5. And there is certainly no 5 as part of this problem. So it does look like this is going to be a single sinusoidal function. Now, to show just parenthetically that this is not automatic, I've drawn here a second problem, except this time I have a 4 here instead of a 6. So this one is 6t, but this other one is 4t. So because these two are not the same, the graph that I get is much more of a mess. And so I would not attempt to make this a single trig function. However, for the problem that at hand here, I have the same thing. I've got a 6t here and I've got a 6t here. And the result appears to be a single trig function. So we're going to talk about how to do that. The process for solving for this is as follows. The first thing I do is to find the amplitude. The amplitude works out to be, it's going to be the square root of 4 squared plus negative 3 squared. So 4 squared plus negative 3 squared, that turns out to be the amplitude. And of course, that's equal to 5. Now, why in the world did I do that? The reason I did that is I'm going to now factor a 5 out of this. So 4 cosine of 6t minus 3 sine 6t. I will now do a simplification that is about the last thing you'd expect me to do, and that's to factor a 5 out. And so I've got cosine of 6t times 4/5 minus sine of 6t times 3/5. Now, the reason I did that, and let me write it as plus minus 3/5 like that. The reason I did that is because I can now write this as 5 times the cosine of 6t times the cosine of theta plus the sine of 6t times the sine of theta. I've rigged this that this squared plus this squared is equal to 1 because I pulled the 5 out. And so I can write this as the cosine of some angle. I can write this as the sine of some angle. And therefore, I'll solve for that angle shortly. And therefore, by a trig identity, I can write this as 5 times the cosine of 6t minus theta. We have a trig identity that says the cosine of alpha minus beta is cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And so this expression can be condensed into a single trig function. All right, now how do I solve for this theta? To solve for this theta, I'll draw a picture. I want the cosine of the angle to be equal to 4/5, and I also need the sine of the angle to be negative 3/5. And so the picture will be down here in the 4th quadrant. So there's 4, there's negative 3, and there's the 5 that I found earlier. And so for this picture, the cosine of this angle would be 4/5, and the sine of this angle would be negative 3/5. All right, now there's several ways to solve for the angle theta here. We could write theta is equal to the arc sine of negative 3/5. That would work. Alternatively, we could write it as the arc tangent of negative 3/4. That also works. And if you plug both of these in your calculators, you get the same answer. What I can't do is write this as the arc cosine of 4/5. Arc sine takes values between negative pi/2 and plus pi/2, so I can just simply take the arc sine arc tangent. However, arc cosine takes values between 0 and pi. So this angle would be actually in the 1st quadrant, so I would need to take negative that angle to be the correct angle in the 4th quadrant. So all 3 of these should be the same. If you plug into your calculator, they should be the exact same thing. And so that's it. And so I can write my solution therefore as, continuing over here, this is equal to 5 times the cosine of 6 times t minus theta over 6. And so the theta over 6 here will match the angle phi that I needed in the problem. All right, so reading off the information, the amplitude is indeed equal to 5, just looking at the number here. The period will be equal to 2 pi over 6 from this 6 here, which is equal to pi over 3, and the units here are seconds, with t's in seconds. The frequency will be equal to the reciprocal of this, so 3 over pi hertz. And finally, the phase shift is going to be the answer you see here, so that'll be equal to 1/6 times theta, which we found to be equal to, I'll just pick this one, 1/6 the arctangent of -3/4. And so that's the phase shift. You'll notice that this is a negative number, and looking at the graph, the shift was indeed off to the left, so that the first cycle started a little bit to the left of the y-axis. So that's the solution. We can write the answer is like this, where theta is this angle here, and we can read off the properties for the graph of the function.